Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video, we write a Java program to find the factorial of an integer n greater than or equal to 0 using loops iteratively. You can find the factorial of an integer recursively as well, for which I am going to post a video separately. So before you begin, it is a request to please subscribe to my channel, because out of 100 views, only 1 or 2 is subscribed and a subscription is very important. So please do subscribe to my channel. Let's begin. So by definition, we have n factorial equal to n into n minus 1 into n minus 2 into n minus 3 till 3 to 1. That is, to find n factorial, you have to multiply all integers from 1 to n. Alright. So 1 factorial is 1, 2 factorial is 1 into 2, 3 factorial is 1 into 2 into 3 and so on. But factorials are defined for n greater than or equal to 0. So by definition, 0 factorial is 1. And then for all n greater than 0, you have to multiply integers from 1 to n to find the n factorial. Okay. So this is what we do in a code using loops. Alright. So I have to complete this method that takes an integer n and returns the factorial of this integer. Okay. In my main, I want to find out the factorials from 1 to 10. Okay. So this is what is the factorial of an integer, and all I have to do is multiply integers from 1 to n into one single product. Okay. So I'll start with the product equal to 1. I will iterate from 1 to less than equal to n. So I takes all values 1 to n. I have to multiply all these values together, which I am going to store in the product. So I'll say product is equals to product into I. And finally I return the product. So basically you are returning the product of all integers from 1 to n. Okay. And that is what our definition for a factorial is. So let me run this. Java C factorial, this is factorial 1. Java factorial 1. 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 3 factorial is 2 into 3, which is 6, 4 factorial is 2 into 3 into 6, 24, then 120 and so on. Alright. Let me change this to 20. Okay. And let's see what output do we get. Alright. So you can see till 10 factorial my output is correct, till 11 it is correct, till 12 it is correct. At 13 I don't have correct factorial because I am supposed to have 2 zeros at least at the end. Okay, because I multiplied 2 into 5 into 10 then into 10, so I should have at least 2 zeros at the end. So this is incorrect. Okay, all this is incorrect. And after 12 factorial I am not getting the right factorial values because the value of these factorials are very large that cannot be accommodated in a int type. Okay, let's use a long type. So I'll say, okay, static long factorial int n. Okay, this is also long then. Okay, all right, and this changes to 2. Okay, so long also holds integer data types but with larger range. So I will, along with this factorial that I'm calculating using factorial method, I also print factorial from this factorial 2 method. So I'm going to say, okay, factorial 2, and I'm going to change a line as well so that I can differentiate between two consecutive values. Okay, so the first factorial output is using this function, the second factorial output is using this function. So second one is returning a long, so we should be able to get factorial values correct for a longer range. So we should have correct factorial values for larger n. Okay, so you can see 11 is okay, 12 is okay, 13 is now correct, 14, 15, 16, 17, 18, 19, 20. All right, let's make it 30. Okay, let's see if long can hold till 30. No, it cannot hold. Okay, this is also incorrect, this is also incorrect, this is also incorrect, this is also incorrect. So after 20 factorial, even long cannot hold larger factorials. And how can you get to know the maximum value a data type can store? So you can say system.out.println maximum value that an int can hold. Okay, it is integer. Okay, this is the wrapper class for int dot max value. Okay, all right, so let me run this. Okay, so the first output is this. Okay, so if factorials cross this, you will go into the negative side. Okay, so you'll get incorrect values. We can find these for long as well. Okay, so I'll say that a long can hold is long dot max value. Okay, compile, run. Okay, so this is the maximum value a long can hold. So this is how you can basically check the range. So this value is basically equal to 2 to the power 32 minus 1 minus 1, and this is equal to 2 to the power 64 minus 1 minus 1. because int is stored in 32 bits and long is stored in 64 bits. Okay, so what if I want to hold factorials greater than 21? So we can use the BigInteger class in java.math. Okay, importing BigInteger from java.math, and I'm going to write another function that is going to return me a BigInteger. All right, I'm going to say this is factorial 3. Okay, since my return value is going to be BigInteger, so I'm going to say BigInteger product. Okay, and I have to create an object of a BigInteger. I cannot say just equal to, this is not a primitive value, so I have to say new BigInteger. Okay, and I have to pass the starting value, which is 1. Okay, I cannot pass an integer or a long value to a BigInteger. Okay, this is not allowed. You have to pass an integer as a string. Okay, so right now we have to create a product with value 1, so passing 1 as a string. Then we iterate this loop, and then we have to calculate the product. So to multiply two BigIntegers, I have to use dot multiply function, okay, of the BigInteger class, and I have to multiply it with another BigInteger that stores the value I. Okay, all right. So we cannot pass an integer to a BigInteger constructor, so we convert this I to corresponding string and then send it. So this is basically creating a BigInteger with value I. Okay, multiplying product with this I and storing back into product, finally returning the product. Okay, in my main I call this as factorial 3. So my third factorial value, okay, is going to be using BigInteger. So I'll say using long, okay, and I'll pass this equal to here, and I'll say using BigInteger. Okay, compile, run. Okay, all right. So let's see that starting factorials, 10 factorial is fine, at 12 factorial is all is okay. At 13 factorial the integer gives up. Okay, till 14 factorial the long is keeping up. Okay, 15, 16, 17, 20. Okay, till 20 factorial long is keeping up, but after that, okay, BigInteger takes over. Okay, even long loses the range. Okay, all right. Okay, so if you want to calculate very large factorials that you cannot store into an int or a long, you can use the BigInteger class. Okay, and there is a limit again to which you can store it in a BigInteger as well. Now you have to tell me how you find that limit. Okay, all right. So this was the solution to this problem, and I hope this was helpful. So if you like this video, if you found this helpful, please do subscribe to my channel. And if there was something that you did not like about this video, please just don't press the dislike button. Please also let me know in the comments what was it that you did not like about this video, so that I can improve upon my future videos. All right, and you can also let me know in the comments if there is a question you want to solve or if there is a concept you want to discuss. Thank you.